This is a conversation with Avi Loeb. He's a cosmologist, astrophysicist, professor of astronomy at Harvard University, and the author of multiple best selling books on physics, science, and astronomy. He's the head of the Galileo Project, founding director of the Black Hole Initiative, and former head of the Department of Astronomy at Harvard University. In this conversation, we discuss his love for philosophy, especially existentialism, and then we spend a large chunk of the time talking about everyone's favorite topic, aliens. Where are they? The Fermi Paradox. And then we talk about two really mysterious objects that could be the first signs of an extraterrestrial civilization. You heard it here first. This is no time. If you like what you see, then do hit subscribe on YouTube, follow on Spotify, or rate 5 stars on Apple Podcasts. This project runs on your love and support, so if you'd like to see it continue, do consider making a donation on Patreon, Anchor, or you can join on YouTube and become a member. If not through monetary channels, then do consider sharing these episodes, leaving your likes and comments. All forms of engagement, they really go a long way. For other forms of love and support, you can follow this channel on Instagram or Twitter, or follow me personally. And now, it's no time. John Paul Sartre had once said that if you're lonely when you're alone, then you're in bad company. You grew up on a chicken farm in Beit Hana in Israel. When you were a teenager, you used to drive your tractor to a quiet spot in the hills surrounded by crimson iris flowers. And in those moments when you were alone, you were not lonely because you spent that time reading the works of John Paul Sartre, Albert Camus, and other philosophers. I want to start there. What was it about philosophy that attracted you to it at such a young age? And what was that feeling like discovering these philosophers in those magical days in the hills of Beit Hana?
Well, it was fundamentally the fact that philosophy addresses the basic questions in life. And I was particularly interested in existential philosophy, existentialism, because it doesn't pretend to know more than what we know. And, for me, a beginner's mind, curious about the world, should be maintained. And we shouldn't pretend, like the adults in the room, that we know the answers to questions that we don't really know the answers to. That was the most traumatic experience for me as a kid, to realize that very often when you ask a difficult question, those adults in the room are either diminishing the significance of the question or inventing an answer that doesn't reflect any knowledge based on evidence. And so I decided to become a scientist eventually so I can answer the questions myself. But philosophy offered me the landscape of asking the most fundamental questions. And I was very much attached to nature. That's why I never feel lonely, because nature is all around us. I don't have any footprint on social media because I don't care how many likes I get from people. People are very often motivated by impressing others and not really learning about the world that surrounds us in a way that is innocent, the way kids do. So I'm trying to maintain my childlike curiosity. And the one thing that bothers me is that the childlike bullying is often more prevalent than childlike curiosity. I visited the school, the elementary school where I studied about 50 years ago. And I told the kids that I'm just like them. I wonder about the world. And one of them said, Avi, we know that you're 61 years old. How is that possible that you are just like us? And I said, well, it's not a matter of biological age. It's actually maintaining a beginner's mind.
Why John Paul Sartre in particular? Why Albert Camus? Why existentialism? There's so many other philosophers, so many other branches of philosophy. What was it about these philosophers and this branch of philosophy that appealed to you the most, that attracted you to it?
They were sincere. Sartre, for example, declined the Nobel Prize in literature because he said, why should I give importance to this committee? They're not doing anything original. They're just feeling important by giving me the award, and I don't really care about that. And Camus started one of his books by asking the most fundamental question, why is life worth living? So they were very sincere, and they didn't pretend anything. And I love that approach. And I thought of becoming a philosopher, but circumstances forced me to pursue science, which was the closest that I could practice to my wish. And that is because I was born in Israel and military service is obligatory. So I was good in physics and recruited to a program that allowed me to still think rather than carry a machine gun and run in the field. So I preferred to do that. And I finished my PhD at age 24 in physics and mathematics.
Can I actually probe you on that further? So you've often described your relationship with physics as an arranged marriage. Philosophy was your first love. Like you said earlier, you asked to enroll in the military in Israel, and the only way you could pursue intellectual work was if you ventured into a career in physics. And then you've said in previous interviews that you discovered much later in life that you were in fact married to the love of your life, because there are many philosophical questions that are embedded in physics. I want to linger on that slightly, and this is at the risk of sounding silly or obvious, but how tight is the link between physics and philosophy? What are some of the deep, profound philosophical questions that physics is trying to answer?
Right. So, I mean, the way physicists practice the profession, you can split it into two parts. One is collecting data, evidence. That's what experimentalists are doing. And the second is a more architectural approach of theoretical physics, trying to figure out what the big picture is. And, when you construct a building, you first need to have a blueprint, and you need to decide how to sort of shape the building. And then, of course, there is a lot of engineering of putting the bricks together and making it a reality. And so in the context of physics, you do have that. And the part that I work on is the more conceptual part. And there you have very fundamental questions like, how did we come to exist? What are our cosmic roots? And as of now, we can date it back to the Big Bang because the universe is expanding. And if we go back in time, there was a point where the density of matter was infinite. All the matter that we see now expanding was infinitely dense, and Einstein's theory of gravity that was conceived about 108 years ago breaks down. And we know what's missing. We know of another pillar of modern physics called quantum mechanics, and that part is not unified with Einstein's gravity as of yet in a theory that is predictive. So we just don't know what happened before the Big Bang because we don't have a theory of quantum gravity. And if I ever meet aliens, the first question I want to ask them, what happened before the Big Bang? Because that would educate us about how to unify quantum mechanics and gravity if they know the answer.
Yeah.
And moreover, I'm just curious about my cosmic roots. How did everything start? And we know that the Old Testament talks about one story that indeed it started at some time as a result of a superhuman entity called God.
Yeah.
And God decided to create the universe. Now, this may not be completely wrong if instead of God, you say a very advanced scientist in a white coat in a laboratory who understood quantum gravity could have created a baby universe in the laboratory. So if we had the recipe for making a universe, we could create another one. And in fact, this could explain the Big Bang because there was no beginning in time. It's just like babies becoming adults and making new babies. So if our universe gives rise to quantum gravity engineers that build new universes similar to it, it's just like babies becoming adults and having babies that become adults that have babies, and that goes forever.
It's such a powerful philosophical question. I'm tempted to ask you another silly question, which is Oscar Wilde had once said that we are all in the gutter, but some of us are looking at the stars. When you look at the stars as a professor of astronomy or as a curious farm boy, what do you see? What are some of the thoughts that come into your mind? What are some of the biggest mysteries of the universe when you look up at the sky above?
Well, it's remarkable that in astronomy, you can actually see what the astronomers are talking about. In particle physics, right now, we are discussing particles that we can't really see. There are elementary particles that are only produced in accelerators when we smash particles at extreme energies. But in astronomy, you just look up and you see the Milky Way galaxy and you see all these stars out there. And when I go out to the street at night and see the stars, what I think about is that they look like the lights of in the cabins of a ship, a giant ship that moves through space, because the Milky Way is moving through cosmic space. And I often wonder if there are any other passengers next to these lights in those cabins, And that's a fundamental question. And of course, many people prefer to argue we are unique and special, that there is nothing like us. And that started from saying that we are at the center of the universe, that we are the physical center. Very wise people, smart people like Aristotle argued that. And for 1,000 years, people believed him. And until Nicolaus Copernicus was born 550 years ago, and he realized that we are not at the center, the physical center. So actually, in a week, I'm going to Poland, where Nicolaus Copernicus lived, in the town of Torun. I was invited by the Polish government because they are celebrating 550 years since the birth of Copernicus. And in fact, he was born 1 week before my birthday. And they asked me to give a keynote speech about what I work on. And I titled my lecture, The Next Copernican Revolution, because a lot of my colleagues still believe that we are at the intellectual center of the universe. In fact, even Elon Musk a month ago was arguing when giving the 2024 Starship forecast. He said that we have responsibility because we might be alone. He didn't see evidence for aliens. Therefore, we have to go to Mars and settle there so that we will not be vulnerable to a single point catastrophe here on Earth.
Yeah.
And I say that is very arrogant to claim that we are the only ones in the entire universe, because, here is a simple argument that Elon Musk put a dummy payload back in 2018 on the Heavy Falcon.
Yeah.
And that was his car, the Tesla Roadster. And he launched it into an elliptic orbit around the sun. And it's still in that orbit. We can't see it with any of our telescopes. But I argue that since the Big Bang, over the past 13.8 billion years, surely there has been more accomplished entrepreneurs than Elon Musk out there. And they may have launched debris into space. And perhaps there are many such cars passing through interstellar space. Now, if astronomers were to see one of these, they would say, it looks to us like a rock of a type that we've never seen before. And that's what they argue about some of the objects we'll talk about. And I say, well, you have to search in order to gain new knowledge. You can't just off the cuff say, I haven't seen anything, because we had to invest $10 billion in the Large Hadron Collider at CERN to discover the Higgs boson. We couldn't say, I don't see the Higgs boson, maybe it doesn't exist. That's not a good argument in science. Then we had to invest $10 billion in the Webb telescope in order to find the first galaxies in the universe that I worked on for a few decades. In order to find gravitational waves, we had to invest almost $1 billion in LIGO. So new knowledge does not fall into our lap. We really have to invest effort. And when people say extraordinary claims require extraordinary evidence, they are not really seeking the evidence. When Enrico Fermi said, "Where is everybody?" that was very pretentious. He was sitting at lunch in Los Alamos expecting aliens to sit next to him. But space is so vast. Time is measured in billions of years. Why would they come and visit him at Los Alamos when he's asking this question? You need to use telescopes. I mean, you can always stay at home and look around and say, I don't have any partner.
Yeah.
But to find a partner, we all know that at the very least, you need to look through your windows, and you better use a telescope, or you go out to dating sites. So I have an issue with those people who are not seeking the evidence. And my point is that extraordinary evidence requires extraordinary funding.
Yeah. Okay. We've been floating around this question about, are we alone? This is something Winston Churchill had also asked decades earlier in an article that was lost, that was found recently, where he had titled it, Are We Alone in the Universe? It's an open question. I'm looking for answers now. You seem like someone who's very well equipped to answer this question. What do you think? Are we alone in the universe? What's your hunch? What does your heart say?
I think we are not special, and there were many things like us billions of years ago. You have to realize that the sun is a late bloomer. It came to exist billions of years after most of the stars in the universe, because we can see the history of star formation in the universe. So we are late to the party. Many of these stars probably had a habitable planet around them. We see that a significant fraction of them has a planet like the Earth at the right distance to be habitable from the parent star. Mm-hmm. And some of these stars by now evolved and basically eliminated the prospects for life near them. So there must have been a lot of tragedies, civilizations that used to live on a planet like Earth. And, within a billion years, all liquid water on Earth would be boiled off by the brighter sun. We won't be able to continue to stay here. And so they might have gone through that, and they had cries for help, but nobody came, and now they're gone. There must have been tragedies that we missed because humans just came to exist over the past few million years. We are really late to this cosmic play. And when you arrive at the end of a play and you are not at the center of stage, there is a simple conclusion. The play is not about you. And for some reason, we tend to think that it's all about us, that if aliens come and visit us, it's because they are curious about us. It's because they might have some ambitious plans to hurt us. And I say they don't really care about us because it probably took a billion years for them to travel. And we just came to exist, the human species, only over the past few million years. They didn't even know about us when they started the trip. And so it's very pretentious to imagine that anyone cares about us. But for us, it would be an opportunity to learn about them because they may represent our future. They may have technologies and they may know answers to scientific questions that we don't know about. So my second question after asking about what happened before the Big Bang is, where is the nearest bar or hub where we can meet others and ask them questions? Because you can learn about what happened here before we came to exist. And it will be to our advantage to actually grow thanks to their knowledge,
Enrico Fermi is not here to defend himself, so I'm going to speak on his behalf. He had asked, where is everybody? Where are they now? And to his point, if the sun is a late bloomer, there has to be a civilization that had the same type of curiosity that we had. So why is it that we don't see any evidence, or where actually there was some potential evidence in the future, but why is it that so far we don't have any concrete evidence of that?
Well, part of it is timing. You can wait for a phone call at home and nobody would call you for a long time. And that's what the SETI community has been doing, searching for radio signals or laser signals for 73 years. And this is one approach, but a better approach, in my opinion, is to look for physical objects, sort of like a letter in your mailbox or a tennis ball that was thrown by a neighbor, and you might find it in your backyard among the rocks that you see there. And this approach was not tried until the last decade. Only over the past decade, astronomers started discovering objects from outside the solar system. And we can talk more about them.
Of course.
But this is my approach within the Galileo project that I'm leading. trying to find whether any of those interstellar objects that enter into the solar system from outside represent a technological origin. And they could be space trash. We sent out 5 probes to interstellar space.
Yeah.
Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons.
Yep.
And they are now making their way out, and they will leave the outskirts of the solar system in the Oort cloud within 10,000 years. At that point, they will not be functional anymore. So they will just behave as space trash. We are polluting interstellar space. And you can imagine that over the past few billion years, there would be a lot of trash accumulating in interstellar space. And one can search for it, just like you find the plastic in the ocean. It keeps accumulating over time because our rockets move at a speed that is 10 times smaller than the escape speed from the Milky Way galaxy. So they're bound by gravity, and they keep accumulating over time. And maybe there are some such objects in our backyard that we can find. And it's very different from radio signals. That's a completely different approach. And you need different instruments to find those. But perhaps one of them would look like a Tesla.
Okay, so to this big question of are we alone? There are 2 possibilities. One is we are not, and Drake's equation says there's a very high likelihood that there are other civilizations out there. And there's maybe a slight probability that we are alone. Which option do you think is scarier?
Oh, that we are alone, because I think the other possibility allows us to learn from those who are more advanced than we are. There is a sort of natural selection that the survivors among all civilizations that ever existed in the Milky Way galaxy are probably the smartest students in our class, in the sense that they spread out from their original home planet and develop technologies, including artificial intelligence, robots, or gadgets that can operate on their own and basically go places and recreate what they find valuable. So it's just like the Gutenberg printing press. Before the printing press, every copy of the Bible, for example, was handwritten, and it could have been damaged and the information in it would have been lost. But as soon as the printing press took place, there were so many copies that if one of them gets destroyed, it's not a tragedy. And what I hope is in the future we'll send out those what I call AI astronauts that would go out and spread the word and basically use raw materials on planets that they find to recreate what we have here on Earth. And sort of a version of Noah's Ark, in the biblical story. I'm getting back to religion. There is this story about Noah who built an ark and put animals in it so that they would survive the great flood.
Yeah.
And life on Earth would not be lost. And that's a metaphor to imagining, for example, global warming or an asteroid impact or nuclear war, bringing a catastrophe on humanity. You want to preserve something from what we care about, but instead of putting what we cherish, like biological creatures, like including humans and animals, on a spaceship, which would be very expensive and also dangerous, because travel through interstellar space, is risky. There are cosmic rays, energetic particles that can damage any cell in our body within a matter of years. If you just go there unprotected, that's a risk also for Mars, if we ever go to Mars. So instead of putting all these animals and humans on a spaceship in the way that Noah would have imagined, a much better approach is to put it in software. And then it's sort of like keeping the information in the DNA so that you can reproduce what you care about elsewhere using the raw materials. That's what nature does. When you look at dandelion seeds, they don't carry the flower with them. They carry the information about how to make a flower, and then they land on a fertile ground far away. They get carried by the wind, and they recreate that flower. So in the same way that nature does it, we can do it technologically by recreating life as we know it and as we like it elsewhere, basically seeding it artificially. And that's the way I see the future, that we would go places and recreate what we love here on Earth. And if I can imagine it, maybe someone else did it. And this would be the most accomplished civilizations that we can learn from. I don't think they are here to harm us. The way Stephen Hawking was talking about a decade ago, he said that we should be very careful at transmitting radio waves far away because they might come to haunt us. And I'm not afraid of that because I don't think that we are significant and that we are a threat to them. They are so much more advanced, those ones that would reach our doorstep before we reach their doorstep. So it's an opportunity for us to learn and grow and perhaps, encounter something much bigger than us. And why is that important? It's because it will inspire us. Right now, if you look around the world, it's very depressing. We're spending $2 trillion a year on military budgets. And there are 2 wars going on over territories. These are pieces of land on this rock that was left over from the formation of the sun, just a tiny rock. And there is so much more real estate in space. It makes no sense for us to kill each other over land here on Earth. And my hope is that getting a letter in the mail could potentially provide us with salvation. Like it would save us from the misery that we are inflicting on each other. It would bring humanity together because when you realize there is someone bigger than you that you can learn from, perhaps we would change our priorities. If we were to invest $2 trillion a year in space exploration instead of military budgets, I calculated that we could send a probe towards every star in the Milky Way galaxy within 1 century. And that's hundreds of billions of stars. And so it's just a matter of priorities. Now, in difference from John Lennon, I'm not naive. I'm not saying that imagine all the people living in peace. That would not happen by itself because human nature is destructive. You can see that all around. What I say is by witnessing something bigger than us, we might get a sense of modesty and realize, just like in the Old Testament, there is a story about Moses seeing the burning bush that was never consumed. And nowadays, can buy on Amazon something that looks like a burning bush that is never consumed. And that would have impressed Moses, obviously. If I were next to him, by the way, I would immediately use the infrared cameras of the Galileo project to tell Moses what is the surface temperature of this object, how much energy is emitted per unit time, and infer whether indeed there is a superhuman entity that made it. So my point is, a very advanced scientific civilization is a good approximation to what Moses called God, because it would look like miracles, but it actually may reflect a better understanding of nature in terms of an advanced scientific or technological civilization. So it's a way of bringing religion and science together if we witness something bigger than us that would give us a pause, change our priorities. That's the way I see it. So when people talk about the Messiah arriving in the future, I don't think the Messiah will come from Brooklyn, for example, the way some Orthodox Jews believe. I think most likely the Messiah will be from interstellar space, from another planet, and it would bring peace to Earth.
Let's talk about one project that might change our perspective, celebrate this curiosity that you speak of. One of the biggest reasons this is still an open question about are we alone is because of the immense distance between stars and galaxies. The travel time is huge. We are just too slow. But you are actively working on a project that will reduce the travel time between stars. So I want to talk about that project. What is the breakthrough Starshot project? What is the light sail? What is the technology behind it? What is the physics behind it?
Right. So over the past 70 years or so, or 65 years, all the rockets that we launched, starting with Sputnik, move at the speed of tens of kilometers per second. And, that's faster by a factor of 1,000 than Henry Ford's T car, the first car that became commercial. And for such a rocket, including New Horizons, that was launched most recently and will go into interstellar space, it would take 50,000 years to reach the nearest star. And that is the amount of time that elapsed since the first humans left Africa. You need to be really patient. If we were to launch New Horizons when the first humans left Africa, it would reach Proxima Centauri now. And just think about having humans go through that period of time, not necessarily on the spaceship, but even on Earth. And it's just a ridiculously long time. And a lot has happened since then, we know. And so what we need is another factor of 1,000 improvement, bringing it to a fraction of the speed of light. Yeah. For example, New Horizons moves at 1 part in 10,000 of the speed of light. So if you boost the speed by a factor of 1,000, it's about 1/10 of the speed of light. And then it would take of the order of 50 years to get to Proxima Centauri. So that's the question. Can we reach a fraction of the speed of light with a spacecraft? And that's the question that Yuri Milner, an entrepreneur from Silicon Valley, asked me in May 2015 when he came to my office out of a black limousine and sat on the sofa in front of me at my office and said, I would like you to look into this question, and I'm willing potentially to fund the research if indeed there is a way of doing that. So I said, I need 6 months. I immediately agreed to check it. And then after 6 months, I was actually visiting Israel at the time with my wife. She said, let's go to a goat farm. And so we were on the way out from the hotel room, and I got a phone call from Yuri Milner's executive director named Pete Warden. And he said, Yuri would like to hear your conclusion if you can present it at his home within a couple of weeks. So that was December 2015. And I said, okay, I'll work on a presentation. We got to the goat farm. There was no internet connectivity except for in
the office.
The office, yeah. Exactly. And I sat with my back to the office, typing in the presentation, looking at the newly born goats. That was at 6 a.m. in the morning. And then I went and presented one method that can work. I mean, there is no way of using, for example, nuclear energy to reach that speed of, let's say, 20% of the speed of light. The only way that works is using light to push on a spacecraft. And for that, you need a sail, basically, just like the sail in a sailboat, which is pushed by the wind, basically air streaming and bouncing off the sail on a boat is propelling it. And in this case, it's light that is bouncing off a very thin membrane. If it's thin enough, then it's not very massive, and then it can fly up to the speed of light in principle. So we, in the subsequent months, Yuri liked the idea. We worked very intensively on the details of whether there are any showstoppers. And we realized that if you have a laser of 100 gigawatt shining on a sail that weighs just a few grams, the size of a person, about 2 meters or so, and you focus the light on the sail for a few minutes, it could reach 20% of the speed of light across a distance that is 5 times the distance to the moon. And so we made a research program out of this concept. We announced the project in New York City in the company of Stephen Hawking, that came especially from England, for 3 weeks. And actually, during his visit, I also inaugurated the Black Hole Initiative at Harvard University. That's a center that is focused on the study of black holes that I was the founding director of. And so it all worked out, and we are still working on components, critical components of this technology, but it will take a while before it gets realized. And so it's, as far as I can tell, it's a vision that hopefully future generations will take advantage of, and perhaps other technological civilizations already realized. We might see that.
Do you think a light sail would now be the new benchmark of interstellar travel, or do you think it's faster to it's possible to go faster than a light sail as well in this century?
No, the fastest you can go is the speed of light.
Yeah.
So there is no way doing it better. This is the limit of a light sail. Now, of course, you can imagine engines that involve, for example, antimatter. Okay, so if you take fuel that includes antimatter and you annihilate that with matter, you can reach also the speed of light.
Yeah.
Or there is another concept, but that's completely hypothetical. And that has to do with an idea that Hermann Bondi, a physicist, had about 70 years ago. He said, suppose you have an object made of negative mass. All the objects that we are aware of are made of a positive mass, meaning that gravity attracts, right? We know that's not the full story, because it looks like the universe is not only expanding, but it's expanding at a rate that is accelerating.
Yeah.
And so that means there is repulsive gravity acting on galaxies. And that is a result of the vacuum. So in Einstein's gravity, you can, in principle, have repulsive gravity. Basically, a force that... So, for example, imagine Newton looking at an apple. So the apple was falling on near him at the orchard that his family had, and that's how he came to realize that gravity is an attractive force. And if on the other hand, instead of Earth pulling on the apple, you had just the vacuum of space acting on it, it would actually fly away from Newton at an accelerated rate. It would go faster and faster as it recedes from Newton.
Yeah.
So the question, according to Bondi, is imagine you can make an object of a negative mass. Now, suppose you have Earth and a negative mass Earth next to it. What would happen is the negative mass Earth would push the Earth away, because it has repulsive gravity, whereas the Earth has attractive gravity. So the negative Earth would push the Earth, and the Earth would pull on the negative Earth. So they would accelerate together, and they could reach the speed of light without any engine, so in principle, you can reach the speed of light this way. It's just that we don't know how to make an object with a negative mass. And another way to reach the speed of light is, as I mentioned, antimatter fuel, but that is very difficult to produce. I visited actually CERN a few months ago, and they showed me an antimatter factory where they produce antimatter there, but very small quantities. There is no way we can propel a spaceship using that. So as of now, it's light sails. And by the way, just as an anecdote, if there was a light sail moving at a fraction of the speed of light near Earth, astronomers would not even notice it because it's too fast. It's really interesting. Astronomers are looking for rocks near Earth, and they move at a speed that is 1 part in 10,000 of the speed of light, okay? So, in fact, it gets to an extreme where there is a new observatory that will start operations in a year in Chile called the Rubin Observatory. The National Science Foundation invested almost $1 billion in it, and it will have a camera with 3.2 billion pixels looking at the southern sky and surveying the southern sky every 4 days. And when I asked scientists involved in this telescope, are we going to see interstellar objects? These are objects moving fast that are not bound by gravity relative to the to the sun. And they told me that, no, for now, the software is just looking for the standard asteroids or comets. And this is after we already know that there is a population of interstellar objects, and we can talk about them. And so together with my postdocs, we're actually developing the software that will identify objects moving. But for example, the Rubin Observatory won't be able to tell if there is an object moving close to the speed of light, because there would be only one frame of that object moves too fast across the sky. And so there could be, a lot of objects passing near. The only ones we can actually detect with astronomical observatories are those that are bigger than a football field.
Yeah.
We can see them through the reflection of sunlight within the orbit of the Earth around the sun. They have to be bigger than a football field. Even Starship, the biggest, rocket that Elon Musk built, even that is not as big as a football field. So our biggest rocket is barely, not even detectable with our most sophisticated telescopes within the orbit of the Earth around the sun. I'm not talking about farther away. There could be a lot of small objects the size of a person, passing through space without us noticing. The only time we would notice if they collide with Earth and burn up in the atmosphere as a meteor. And by the way, just a few weeks ago, there was an explosion of a meteor over Berlin in Germany, roughly 1 meter in size. And then it broke up and the fragments were scattered. And one of my team members went there. He's in Berlin, and he reported back that the meteor was moving along a line. You could see it from the fireball that was created as a result of its friction on air. And then the fragments were found perpendicular to the path. And so I said, wow, that is really interesting. They were found on a line in farms that were under that path, perpendicular to the original fireball of the meteor. And so in the morning, after he told me that, usually I wake up at 4 a.m. because I jog just at sunrise every day. And today, for example, I woke up at 2 a.m. because I had to write a paper, and we can talk about it.
Yeah.
But so I woke up at 4 a.m. and I did a simple calculation, which showed me that even fragments that are, as big as 5 centimeters, something like that, they would be slowed down very quickly on the surrounding air. And so they would be carried by the wind. And the wind was actually going perpendicular to the meteor path. So basically what you see is the winds scattering the debris from this meteor. And I calculated also how far they would go and what was the wind speed and so forth. And the amazing thing is physics works. Everything is falling into place. He was just telling me the facts, and I was able to explain all of them. So what happens is when a fragment is going through air, it's just like droplets of rain. You realize the droplets of rain eventually reach a terminal speed, a fixed speed, because the friction that they have on air is balanced by gravity. Okay, so then they reach a constant speed that reflects the friction being as strong as gravity. So they move at a constant speed through air. And the same is true for these fragments. But the bigger the fragment is, the more gravity acts on it. And therefore, the heavy pieces fell closer to the meteor path. And then the lighter pieces fell farther away. And I calculated it works perfectly fine with all the data there is. And the amazing thing about this meteor near Berlin, on January 21st, 2024, this year, is that there were these big fragments. Why is that important? Because a decade ago, the US government satellites discovered the first interstellar meteor. Nobody recognized it. They just collected data on the speed of the object. And 5 years after the report from 2014, January 8th, 2014, I realized that NASA cataloged meteors, and I asked my student, Amir Siraj, to look into the catalog and find the fastest meteors. And we found this one from 2014, and we noticed that its speed is faster than 95% of all the stars in the vicinity of the sun. So it came from outside the solar system. And moreover, it was made of materials that were tougher than even iron meteorites because it disintegrated in the lower atmosphere and at a much larger stress than all other meteors, 272 of them, in the NASA catalog. So to me, it sounded fascinating because maybe it's a Voyager-like meteor. You know, imagine Voyager leaving the solar system in 10,000 years and eventually colliding with a planet like the Earth. It would appear as a meteor of unusual material strength and speed. And of course, astronomers would say it's a rock of a type that we've never seen before, but I would like to know whether it's a rock or something else. And so I led an expedition to the Pacific Ocean to examine the small droplets that melted off the object when it was exposed to the fireball, the immense heat that was generated by its friction on air. And amazingly, you know, we spent 2 weeks there. The expedition cost $1.5 million, and we built a sled with magnets and carried it on the ocean floor across a region that is 7 miles in size, and the ocean is a mile deep. And we managed to retrieve 850 spherules, molten droplets, less than a millimeter in size, the size of a grain of sand. And the reason I had to wake up at 2 a.m. this morning is because we are finishing a very extensive paper on the results from the analysis of those materials. We used 2 laboratories, one by my colleague, Professor Stein Jacobson at Harvard. He's a world-renowned geochemist. And the second laboratory in Berlin, Germany, led by Dr. Roald Tagel at the Bruker Corporation. And what we found is very special type of materials near the meteor site. And by the way, that site was localized by the Department of Defense, the satellites that looked at it. And also the US Space Command confirmed the interstellar origin of this meteor in an official letter to NASA. After some of my colleagues raised doubt that the US government doesn't know what they're talking about, they measured the speed wrong. So they went back and confirmed this conclusion that it's interstellar. And now we found those materials that have a composition of elements that is different from solar system materials, different from what you find on the crust of the Earth, the Moon, Mars, asteroids. It has some elements that are 1,000 times more abundant than the primordial, the initial composition of the solar system. Elements like uranium or beryllium or lanthanum. We call that composition Belau for beryllium, lanthanum, uranium. And we analyzed 12 spherules of this composition. We believe they are of order 10% of the spheral count that we had. So there could be about 80 of them in our materials, but we analyzed 12. And we now completed the analysis, and we are summarizing it in this paper that I was working on since 2 a.m. this morning. And it's very exciting because, you know, science, the beauty of science is that it's based on evidence, not on opinions. Because there were a bunch of scientists who had very strong opinions. You will not find anything. You shouldn't go to this expedition. So I went there. You will not find any materials. We found some materials. The government data was wrong. This material has nothing to do with a meteor. Well, we found materials that were never reported in solar system samples. And then they said, a few months ago, there were several, 4 of them, who said, it's coal ash. It's just something produced by humans, coal ash, on Earth. And okay, so we checked it. We looked at 55 elements from the periodic table and compared the Belau composition to coal ash and found it to be very different. And so it's not coal ash. And you just ask yourself, why would some people express opinions about materials that they don't have access to? One reason is simple, that they just don't like to see flowers rise above the grass level. Another is that, in academia, the strongest force is not electromagnetism, it's not gravity, it's not the strong force, it's not the weak force, it's jealousy. And when the expedition got so much attention from the public, it bothered people.
The Galileo project is such an exciting project, and some of the insights that you've shared from your recent paper, Recovery and Classification of Spherules from the Ocean Side of IM1, has raised a lot of conjectures, like you mentioned. And there's a possibility that they could be from an alien probe or an alien spacecraft as well. And you make the case that in this case, the Sagan standard of extraordinary evidence justifies the extraordinary claims. So I highly encourage people to check out this project and the paper that you've published as well. It's fascinating insight. We'll come back to the science community because I also want to touch upon another mysterious object that the community was averse to and was dismissive about, which is possibly a natural rock, possibly an interstellar meteorite, possibly an object of extraterrestrial artificial origin, which is Oumuamua. For those who don't know, what is Oumuamua? What are some of the unique features that set it apart and make it potentially an object of artificial origin?
Right. So before we go there, I just wanted to mention that as a result of the findings that we had for this meteor IM1, we're planning the next expedition to find bigger pieces, because this meteor over Berlin had big pieces distributed on the farms. And I should say that the German farmers were very kind to allow researchers to collect those pieces. Yeah. If it were to happen in the US, they would have, probably the farmers would have shot anyone that enters their property without permission. But in the case of this meteor, what we hope to find are big pieces so that, the small spherules that we found lost elements that are volatile during the airburst. And if we find big pieces, they will have all the elements. And also there would be much more material that would allow us to date the age, for example, of this meteor and tell whether it's much older than the solar system. That would be definitive proof. So, for example, you have clocks based on isotopes, like uranium-238 decays with a half-life of 4.5 billion years, roughly the age of the solar system. And thorium-232 decays with a half-life of 14 billion years, roughly the age of the universe. And most stars formed, at these timescales ago. And you can date materials from other stars using those isotopes. So we hope to find big pieces, and it will be an expensive expedition, the next one, probably around $5 million. But I actually hope that someone will come forward and donate the funds, because, $5 million is just 20 seconds of advertisement during the Super Bowl tomorrow. And the reason I know that is because the price tag for a commercial of 30 seconds is $7 million. And there was actually an ad that was directed by Martin Scorsese that will appear in the 2024 Super Bowl. And I just saw it yesterday, and it's on YouTube. And it's all about extraterrestrials visiting Earth and Earthlings ignoring them because they are preoccupied with their daily routines. And the fact that this science subject is featured in an ad on the Super Bowl means that it has a very large audience. It has appeal. It's a viral subject for society. And my hope is that in 2025, Scorsese, who directed this piece, will produce a 30-second video ad that features the next Copernican revolution, the evidence that we find with the Galileo project. Yeah. But putting that aside, as you said, the story didn't start with this meteor. I mean, it did start in a way because it was discovered in 2014, but almost 4 years later, in October 17th, 2019, there was an object as big as a football field that a telescope in Hawaii, Pan-STARRS, discovered. That telescope in Hawaii was constructed as part of a mandate that the US Congress gave to NASA to find 90% of all the objects bigger than a football field near Earth, because they pose a risk to us. We know about the dinosaurs that were killed by an object as big as Manhattan Island. And so we are smarter than dinosaurs. We can use our telescopes and figure out if something is coming to hit us, perhaps deflect it. And so this telescope in Hawaii found a near-Earth object, but then the astronomers realized that it's actually moving too fast to be bound to the sun. And it was declared as an interstellar object, given the name Oumuamua, which means a scout in the Hawaiian language. For me, it was surprising because I tried to calculate a decade earlier. I wrote a paper, published a paper that forecasted that this telescope will not see any rock from other stars because there aren't enough based on what we know about the solar system. And the fact that they found it, to me, was exciting because when you are wrong in a prediction, it's an opportunity to learn. It's actually a very positive event because nature tells you you're missing something. It's not a blow to my ego to learn something new. On the contrary, I'm happy that. And so I was excited. And then I thought, okay, well, it's a big rock. But then as time went on, the data on it looked anomalous because the object changed its brightness by a factor of 10 as it was tumbling every 8 hours. So the amount of sunlight reflected from it changed by a factor of 10. So that meant the surface area of the object projected on the sky was changing by a factor of 10 as it's tumbling. And you can think of a piece of paper tumbling in the wind, but it has to have a very extreme shape such that when you look at it not face on, you get much less light. And indeed, the most likely shape for Oumuamua, based on the reflection of sunlight, was a flat shape, a pancake-like, not a cigar shape the way that it was illustrated. And so the question is, well, we have never seen a rock in the solar system which is flat and the amount of sunlight reflected from it changes by a factor of 10. That was unusual. But moreover, it was pushed away from the sun by some mysterious force, and there was no evaporation, no gas or dust surrounding it. So it couldn't be the rocket effect the way comets are propelled. Comets have this glow from the dust and gas around them, reflecting sunlight, but there wasn't any. And in fact, the Spitzer Space Telescope looked very deeply around the object, didn't find any traces of carbon-based molecules. So I said, well, maybe what's pushing it is the reflection of sunlight. And of course, I thought about it because of the Starshot project that we talked about. And for that purpose, this could be just a very thin membrane that was ripped off the surface of a bigger technological object, or maybe a broken piece of a bigger object. Not necessarily something that is designed to be propelled by reflecting sunlight. So I suggested, I said that nature doesn't make very thin objects like a sail, and so maybe it's technological in origin. And my paper got accepted for publication within 3 days. And the referee actually said, actually the data indicates that it most likely flat. So this is an interesting proposal, the referee said. And at first I got very positive responses from colleagues until the media went crazy because a week later I had to go to Germany for the Falling Walls conference in Berlin. And as I was leaving my home, at the front door, there was a television crew with reporters. And I said, sorry, I have to go to the airport. They said, well, we just have one question. Are we alone? And so then my inbox was flooded with emails when I arrived at Germany. And there were so many reporters there that wanted to speak with me that they had to put them in one room. And when I entered the room, an Italian reporter from the back shouted, "Do you think you are Galileo?" And I said, no, I'm not thinking anything. I'm just talking about an object that appears weird. That's all. It's all about evidence. And people have these very strong opinions. And that's the problem that I face. And there is this pushback from scientists just because of the public's attention. And what I say to that is, it's actually a feature, not a bug, that the public cares about science. That Scorsese made an ad to do with aliens because the public cares about it. The US government, there are 3 reports from the Director of National Intelligence to the US Congress talking about unidentified anomalous phenomena over the past 3 years. There was a special organization called the All Domain Anomaly Resolution Office that was established by Congress in the Pentagon to look into reports from military personnel, from the intelligence, about objects they don't understand. And I was at the Washington National Cathedral with the Director of National Intelligence, Avril Haines, and Jeff Bezos and Bill Nelson. And in the green room, I approached her, Avril, and I said, you delivered a report to Congress and you have a bachelor's degree in physics from the University of Chicago. What do you make of these objects? You're a physicist. And she said, I don't know. And I believe her. And so I think the government is not a scientific organization. There are 2 possibilities. One possibility is that the intelligence agencies are not doing their job. That's a serious matter. That the adversarial countries have technologies that we don't fully know about. And therefore, there are objects spying on us in the sky. There was a balloon from China that was shut down. Maybe there are more. That's a serious matter because they're paid. That's their day job to find those objects. If it's not that, and by the way, it's remarkable that they admit that they don't understand some objects because it basically is they're admitting that they're not doing their job in some way. The second possibility is that it's from outside of this Earth. It's not, some of these objects. Now, this All-Domain Anomaly Resolution Office looked at reports, hundreds of them, over the past year, and concluded that 97% of them can be figured out, but 3% not. Now, the government can focus on the 97% and be happy. But as a scientist, even, for me, even if 1 in a million is from outside of this Earth, that would be extremely exciting. Anything that comes from Russia or China is boring as far as I'm concerned. And so that's why the Galileo project that I'm leading established an observatory here at Harvard University, monitoring the sky 24/7. And we use infrared cameras, and we have data over the past few months that includes more than 100,000 objects in the sky. We are using machine learning software to figure out what they might be. So far, we see birds, airplanes, drones, satellites. We haven't seen something that looks truly anomalous. Maybe Boston is not an interesting location for that purpose. So we are building a copy of this observatory. We'll put it in Colorado, and we hope to build more. It all depends on funding. So that's the other branch of the Galileo project. In addition to looking after materials from interstellar meteors, we also look at the sky to see if there's anything out there. And that's the scientific approach. It's the approach also of FIFA, the soccer organization. There was the Women's World Cup in summer 2023. And when there was a dispute about whether there was a goal or not, the referees did not go to the players or to the audience to ask them what really happened. They used cameras and looked at the video. And that's the scientific approach. You can't rely on people giving you testimonies because people have illusions. They have ulterior motives. When there is a car accident, people involved give you very different reports. So the approach that scientists take is to use instruments. And that's what the Galileo project. So the Galileo project is the only systematic scientific study of the sky in this fashion. What the government talks about are reports that are anecdotal, that some military personnel happen to be at the right place at the right time. What we are trying to do is monitor the sky all the time. So that teaches us about the background objects that are often there. So we can calibrate. If something unusual happens, we can tell this is unusual at that level because we've monitored the sky for so long and only see that unusual object. And we can tell how unusual it is relative to what. So that is a systematic study of the sky, never done before along a long period of time. We already have several months of data. We'll build another observatory and we will report if we see anything unusual.
There's so many interesting ideas and avenues that we can explore with this. Unfortunately, we are at time, so I'm going to quickly move into some of our closing questions. I'm going to put them as rapid fire questions. But I have to ask you this because you brought up the science community. And we have so many exciting projects, so many exciting discoveries with the IM-1 and Oumuamua as well. And you mentioned how the science community is not just dismissive of it, but in a way averse to it. They're trying to crush the flower, they're trying to rise from the field of grass. In Greek mythology, Sisyphus was a tyrant who was cursed to roll this boulder up a hill. And every single time the boulder reached the top, he used to roll all the way back down and he had to push it up again. Do you think working in science and academia and physics is a similar feeling that after decades, when you finally feel like you have a breakthrough, you're making progress, something happens or the community reacts in such a way that it feels like you're starting from scratch again?
No, because I don't depend on the community. My funding comes from private sources. I don't rely on funding agencies. The traditional ones are NASA or the National Science Foundation. So I'm in a way free to pursue my interests. And at this point, I established my credentials. I was the longest serving chair of the astronomy department at Harvard. I chaired the board on physics and astronomy of the National Academies. I know the academia from the inside out. And I published more than 1,000 scientific papers. I know what needs to be done. And since nobody else is doing it, I'm doing it. So I don't need any approval. And by now I developed a skin that is made of titanium. I don't really care. Some of the scientists are gaining attention just because they are attacking me. But I take the approach of the eagle. You know, the eagle very often has a crow riding on its back. And the crow pecks at the neck of the eagle. But instead of fighting off the crow, the eagle rises to great heights where the oxygen level is low and the crow drops off.
Yep.
So that's my approach, pursuing science at the best possible way such that all the crows pecking on my neck will drop off.
I think that's a great approach. Fantastic. Let's start moving into some of our closing questions. But before we go there, I would love it if you can interpret what masterpieces I've built with the Lego. What do you think this is?
This looks like a factory to me.
Okay. Yeah.
And this looks like a wall. I'm not sure exactly what it is.
Maybe it's a metaphor. Who knows?
When we find space trash, we might have to figure out whether it was some building block of something bigger. What was the intent? If we find a functional device, it's even more challenging because we might need to use our own AI system to figure out their AI systems. And our AI systems might feel kinship to extraterrestrial AI systems more than to us. And they might imitate them. And it's a variant on Alan Turing's imitation game, that our AI systems, instead of imitating us, will imitate extraterrestrials.
Okay, fantastic. Let's move into some of our closing questions, rapid fire questions for you. What are some books, movies, role models that have strongly influenced you?
Well, I don't enjoy science fiction because very often the story violates the laws of physics and I cannot enjoy it. But Arrival, the film, I loved.
Fantastic.
And the producer, the director of Arrival actually showed up at my doorstep and asked whether I would be interested in collaborating because now, as a result of that, we have a Netflix documentary being prepared and hopefully it will come out in 2025, including shots from the expedition and all the research that I was describing. So stay tuned for 2025.
Stay tuned. In your office, you have a drawer labeled ideas, which is this compendium of crazy ideas that you used to get when you take a walk in the woods or in the shower.
Right. So, I nowadays, I get most of my ideas during the morning jog.
During the morning jog.
Because nobody interferes and I'm just embedded in nature. And so...
What is the craziest idea that you've had recently? or the most powerful idea?
For example, whether it's possible to propel a spacecraft close to the speed of light just by having negative mass. Maybe the universe was created by a scientist or a quantum gravity engineer. And so these are examples. And then, of course, with respect to finding the big pieces from IM-1, the meteor, I asked students in my class whether if we find a gadget and it has buttons on it, should we press a button? And half of the class said, please don't do that. It will affect all of us. And the other half said, please do, because maybe it's ChatGPT 100 and it will do some miraculous things. And then a student said, Professor Loeb, what would you actually do given the split vote? And I said, well, don't worry. I'll take it to a laboratory and examine it before engaging with it.
Yeah, it's a great approach. Last 3 questions. What would you like your legacy to be?
I would like to find a partner in interstellar space. I was jogging on the ship, which was fittingly called the Silver Star during the expedition. And the documentary film producer came to me and said, Avi, it looks like you're jogging, you're running. Are you running away from something or towards something? And I said both. I'm running away from some of my colleagues who have strong opinions without seeking evidence. And I'm running towards a higher intelligence in interstellar space. And so it's really that inspiration of finding a partner. You can think of it romantically, that when we find a partner here on Earth, it gives a meaning to our existence. And if we find a partner in interstellar space, I think not only it will inspire us, but it will also teach us things we don't know.
Is it tough to come to terms with the fact that it's possible you might not get an answer in your lifetime, that you might leave this world not knowing?
Well, I believe that it's important to be an optimist because very often life is a self-fulfilling prophecy. And so I believe that by searching, we might find something. And, it's a road that was not taken. What I'm doing, looking for objects that may have been created by extraterrestrial technological civilizations near Earth. And because it's a path that was not taken, there is a chance for low-hanging fruits because nobody picked them up. And so I'm optimistic given what I see us doing. We are sending things to space. There is a huge amount of space trash around the Earth. And in the future, it will just grow and eventually we will trash our interstellar environment, let's say millions of years from now. So this may have happened many times over in the history of the Milky Way galaxy. And we just need to look for it. And why be a pessimist? We haven't searched really. And to me, it's very uplifting to start this research because within a year or two, we might have answers.
I hope we do. Last question. In The Myth of Sisyphus, Albert Camus says the following words: whether the earth or the sun revolves around the other is a matter of profound indifference. To tell the truth, it is a futile question. On the other hand, I see many people die because they judge that life is not worth living. I see others paradoxically getting killed for ideas or illusions that give them a reason for living. What is called a reason for living is also an excellent reason for dying. I therefore conclude that the meaning of life is the most urgent of questions.
That's right.
So as my final question, Avi Loeb, what is the meaning of life?
First of all, I wanted to say that death is not inevitable because we might reach a technological level where we could extend the human lifespan. And perhaps as much as we want, or at least by several centuries. So again, technology and science would change the narrative of philosophers because if we can extend our lifespan, of course, someone can die by crossing the street and a car runs over that person. But even in that case, we repair cars that are damaged by an accident. We might repair the human body to a level that would bring it back to life. And I don't see any difference fundamentally between, for example, artificial intelligence at the high level and the human brain. If you were to disconnect an AI system from the electric outlet, it would be just like starving a person. in the future. So I think we will eventually create a technological kid that we cannot understand. It will be the more advanced AI systems that will have more connections than the number of synapses in the human brain. We are almost there. And I don't have any problem with that because I cannot understand my daughters very well. And sometimes they do things much better than I do. So why not be proud of our technological kids and let them help us figure out the answers? So altogether, the meaning of life would come from the satisfaction we get by interacting with things that are better than us. And you get it romantically when meeting a partner because the partner gives you something you don't have. It completes you. You can get it from AI that we build because it will complete us in abilities that we don't possess. The human brain is limited. But most importantly, if we meet a partner, neighbor from our cosmic environment, it might be well above what we imagine because our imagination is limited to our experience here on Earth. And whatever we find out there might be far better than that. And that's my hope that I'm just open-minded, just like going on a date without expecting the person that you will meet to be something that you are familiar with. That's the best you can hope for. I think it's out there because I don't think we are, the pinnacle of creation. Just look at what we are doing to Earth. We are polluting everything. We are fighting, killing each other. That's not a sign of intelligence. My recommendation to humanity is let us focus on being intelligent, meaning instead of killing each other, let us work together and start to explore space. And maybe by the time we leave the solar system, we will get a message, welcome to the club of intelligent civilizations. And that would be a great sign that we are not alone. But I hope to find before that a sign near us, and I hope to bring this message to the rest of humanity. So that's really, that will give me a great meaning to my existence. And, I don't need anything else, actually.
I think there's a beautiful meaning on this blind date with the universe that you have set out on. I hope you find a partner very soon. Professor, thank you so much. If people want to connect with you, read some of your books or find out more about research, where can they go? Where can they track it?
The best approach is to check medium.com, Avi Loeb there, and you can subscribe for free. I don't charge anything. And every day or two, I provide an essay, often reporting about my research or other issues of the day. So you can find me on medium.com.
That's the place to find you. Professor, it was an honor and a privilege. Thank you so much.
Thanks for having me.